This is Pre-Calculus A, Unit 2, Lesson 2, Function Algebra, and particularly the algebra of functions. In this lesson, we're going to be taking functions like f of x and g of x, f of x and g of x, and we're going to be adding them, subtracting them, multiplying them, and dividing them. So let's say, for example, I have 1 over x plus 2 for f of x. And g of x, I've got g of x, I've got x minus 3 over x plus 2. All right? So we've got two functions, and we can do all these things to them. We can add them, subtract them, multiply them, divide them. We can also compose them. Composition is subject for the next lesson, so I will save that. Okay? But here's the idea. I can take and add them. So we can add f of x and g of x. F of x plus g of x. See if I can keep with the color scheme here. F of x plus g of x equals, okay, f of x plus g of x is 1 over x plus 2, 1 over x plus 2, plus x over 3, x minus 3 over x plus 2. Okay, and for addition, that turns out kind of nice because the denominators are the same. So we have common denominators. 1 over x plus 2 plus x minus 3 is 1 plus x minus 3 over x plus 2. Or simplifies to 1x or x minus 2 over x plus 2. Okay, now when it comes to domain, of course, there are some restrictions. So the domain, we cannot divide by 0. We can't square root a negative. Okay. Now you must apply the domain restrictions before simplifying. So we can't have the domain via the denominator be 0 anywhere. So x plus 2 luckily is the only denominator that appears. So x plus 2 cannot equal 0. Therefore, x cannot equal negative 2. Right? And I would say the domain in interval notation would be negative infinity to negative 2 union negative 2 to infinity. To infinity and beyond. All right. So that's addition. I'm not going to take the time to do the subtraction, but it's very much like addition. Just do remember that when you subtract, we're going to distribute the minus sign to the x and the 3, so we'll have negative x plus 3. So beware of your signs. All right, let's go ahead and multiply f of x and g of x. So f of x times g of x. Now, mind you, this is a dot, not a circle, and it's really important that you not do a circle. F of x circle g of x is for composition, and it's a different operation. Okay, so if you're in the habit of making your periods or your dots into circles, avoid it. For this lesson, for mathematics, because it's a different, it means something different. So f of x times g of x, okay, and we simply multiply the two functions. F of x, 1 over x plus 2, g of x, x minus 3 over x plus 2, multiply straight across, okay. 1 times x minus 3 is x minus 3. X plus 2 times x plus 2 is x squared. And I'm going to leave it as x plus 2 quantity squared. We could square it, we get x squared plus 4x plus 4. All right? But we want to be able to simplify if we need to. Okay? And so that's the product f of x times g of x. Again, domain restrictions. The domain, again, we can't let x plus 2 be 0, so x cannot equal negative 2. Negative 2. All right. All right, so let's jump ahead now to division. F of x divide g of x. F of x divide g of x. Okay. This one's a little more complicated. F of x is 1 over x plus 2. G of x is x minus 3 over x plus 2. We're going to divide. And recall that divide means take the reciprocal of the denominator and multiply. Okay? Yours is not to reason why, but to invert and multiply. All right? Because taking the reciprocal, basically division is multiplying by the reciprocal. All right, so x plus 2 over x minus 3. X plus 2's cancel, leaving 1 over x minus 3. Now you might be tempted to say, well, x can't equal 3, and that would be correct. But remember, you've got to evaluate the domain before simplifying. And we can never, in any of the process, be dividing by 0. So if I look at it right here, here's a denominator x plus 2, here's a denominator x plus 2, here's a denominator x minus 3, here's a denominator x minus 3. Nowhere can we ever divide by 0, so we cannot let x plus 2 equal 0. Neither can we let x minus 3 equal 0. So x cannot be negative 2, and x cannot be positive 3. Therefore, the domain in interval notation is negative infinity to negative 2, union negative 2 to 3, union 3 to infinity, and beyond. Right? So be aware of that. When you're checking for domain restrictions, don't just check the domain restriction after simplifying. Check the domain restriction immediately after, and then also at any stage throughout the process. You cannot divide by 0. All right, hopefully that helps. Good brief 7-minute introduction to this unit.